Good morning students. So in this class we are going to discuss about distance, displacement and displacement vector. So distance is the actual path length travelled by an object in a given interval of time during the motion. So for example, an object moved from initial to final through this path. So this is the actual path length travelled by an object during the motion in a given interval of time. So distance gives the magnitude. So it's a scalar. Then displacement. So displacement is a vector. So that is the shortest distance between the two positions of an object. So this is the initial position of an object. This is the final position of an object. So it's the shortest distance. Then its direction is from initial to final. So the direction is from displacement is from initial to final. So it's the shortest distance between the two points. So one is initial and final. So it's the shortest distance between the two positions of an object. So displacement is always less than distance. So consider an athlete runs 3 rounds of radius 50 meter. So what is the distance and displacement? So an athlete completed 3 rounds. So what is the distance? So distance, that is, it's a circle. So it's 2 pi r. It's the circumference of the circle. So we know the radius. So into 3 you will get the answer. Then displacement. So this is the starting point and also this is the ending point. So in this case displacement is 0. Distance you will get some answer. So that is 3 into 2 6, 16 into 3 18, 18 into 5 that is 90. So 900. So it's around 900 meter. So and he covers 3 rounds, that is the actual path length travelled by the object. So an athlete complete 3 rounds of radius 50 meter. So the distance and displacement we can clearly understand from this problem. The next, displacement vector in Cartesian coordinate system. So here we consider x and y. So now particle is at the point P1 then P2. So the particle move from here to there. So P1 to P2. So R1 and R2 are the position vectors. So the position vectors describes the position of the particle. So in xy coordinate at R1 is represents, that is xi, that is x1i plus y1j plus z1k. So if it is a 3-dimensional case, then R2 is x2i plus y2j plus z2k. So it represents a position. Then the object move from P1 to P2. So there is a displacement. So the displacement delta r equal to R2 minus R1. So this is R2, this is R1. So R2 minus R1 will get the displacement vector in our Cartesian coordinate system. So that is x2 minus x1, y2 minus y1, z2 minus z1. The next, so consider this problem. So R1 and R2 is the position vectors. So consider the particle move from P1 to P2 in xy coordinate. So R1, what is the position here? Just see, it's 1 comma 1. So x and y is 1. So that is I cap and j cap. That is the position vector R1. Then R2. So just see, it's 4 comma 2. That is 4 is x. Then 2 is y. So 4i plus 2j cap. So what is the position vector? That is a displacement vector delta r equal to R2 minus R1. So 4 minus 1, then 2 minus 1. So 4 minus 1 3, then 2 minus 1 1. So 3i cap plus j cap, that is the displacement vector. So the vector represents the direction. That is, what is the magnitude? That is square root of that 3 squared plus 1 squared. 3 square 9, 9 plus 1 10. Square root of 10 units is the unit. That is the magnitude of, that is displacement vector. So in this class we have discussed distance, displacement and displacement vector. So displacement vector delta r equal to R2 minus R1. Then we have done one problem. Then distance, it's an actual path length travelled by an object during the given interval of time. Then displacement is the shortest distance between the two positions of an object, that is initial and final.